This video is going to be covering comparing two proportions, specifically in examples. I'm going to be doing one practice example dealing with a 95% confidence interval, and then one example dealing with completing a hypothesis test. At any time, I do recommend that you stop and make sure that you have completely read through the entire problem, because I'm just going to get ready and just start going. Now, the first thing that I advise doing in every single problem is to begin by identifying what your proportion of interest is. Remember, you want to make sure that this is in context. So for this guy, my proportion, my P, is the proportion of patients reporting drowsiness. Now notice I'm not making a distinction here between which brand of medication was being used, because I'm going to be doing that when I actually go through and start working it through. I will be denoting with the sub I, the brand I medication is my improved, and with a sub C, I'm going to be talking about the brand C medication, and that's the current brand. Remember, because what we're doing here is we're comparing the difference in side effects between my improved brand and my current brand. It's also probably going to be beneficial for me to identify the fact that what I want to know is very specific. I'm going to be doing, I'm going to state this right here. It's always important for you to state this particular step. I'm going to be mentioning what order I'm going to be doing my comparison in. I'm going to be doing the proportion of improved brand minus the current brand. That helps me understand which problem for my final conclusion is bigger. If my interval is all positive, that means that the very first option, the improved brand, was the larger one. If it's negative, that means the current brand was the larger one, the larger proportion. Now, in working these problems, I always like to write down exactly what all of my given information is. This really isn't an option. This is something that you need to do. They expect to see all of the used statistics listed out. So let's go ahead and do that. For the improved brand, I'm going to denote this with X sub I. That is my number of successes from the improved brand. That number, it said, let's see here, where is that? 14 of the 80 patients with brand I reported drowsiness. So 14 out of 80. For my brand C, that is 22 out of 80. I'm also going to report upon the fact that I want a 95% confidence interval, because that's going to come in handy here also. So my confidence level is 95%. Okay. Now that I've listed out everything that we have, it's important to actually stop and take a note and mention, is this something that you can do? Which means, have we met our assumptions and conditions? For my assumptions and conditions, remember my assumptions are independence, random, success failure, and small enough sample size. And then when comparing two proportions, we also have to establish that those two proportions are in fact independent. Now, this was an experiment. So unfortunately, that means that you usually cannot randomly select your subjects from an experiment. So what we're going to have to say here is that we hope this is going to be a representative sample. Okay. We cannot talk about randomly assigning subjects to this experiment, simply because when we're talking people have to volunteer for this. However, we can say that the subjects, or let's even call them patients, are randomly assigned the treatments. Now, that allows us to say the groups are independent. Now we get to deal with the actual sample size. Now also, some people will say that when you're talking about an experiment, you don't actually have to have the 10% condition. I believe you should always make it known, and that is because just in case you have a grader who doesn't feel that's true, you don't want to make that mistake. So we know that 160 is going to be less than 10% of all people, and let's just say people with allergies. Okay, then we're going to list out our total successes and failures for each group. We don't need to actually really calculate an NP and an NQ here because we're given successes and we're given failures. So I'm just going to list them out. 14 successes from group 1. The flip side of that is going to be 66 failures. We have 22 successes from group 2, which is going to relate to 58 failures. For each of those are greater than 10, so large enough. Now what we get to say is that conditions met, so our sampling distribution is approximately normal. Normal enough to us to allow to use the z-scores. We're going to proceed, not precede, with a two proportion z interval. Okay, the two proportion z interval is the name of the test. So there are really two pieces to this condition. We are saying the conditions met, the sampling distribution is normal. You are going to have different types of distributions that you can have, and then we actually have to state that this is a two proportion z interval. Now, we actually get to the math of it all. In conducting a two proportion z interval, we actually are going to be doing a majority of our computations on the calculator. There's still information that we have to state, and this makes it known that we understand what we're doing, we know what each of these numbers represent, and we know what the process is. It just also means we don't have to go through and do all the computations ourselves. So, the formula for a two proportion z interval, and this is something that you would not need to write down, is that my confidence interval is the difference between the proportions plus or minus your z star and the standard error. This here is the standard error, and the standard error is always centered around the samples for a confidence interval, so I should only be using my numbers from the samples. So up on top, we do our p hat 1, success from the first group, failure from the first group, size of the first group, always plus success of the second group, failure of the second group, size of the second group. Now, you don't need to write that formula down if you list every single aspect up here. Now, I didn't list down what p hat 1, p hat 2, z star, all of that was, so putting this in here is very, very helpful. Now I'm actually going to do my computations. So I am doing, just like I stated before, we're doing improved brand minus the current brand. So that means that I'm going to have 14 over 80 minus 22 over 80 plus or minus. Now for z star in this case, z star is my critical value for a 95% confidence interval. So to do that, remember how to do that on your calculator. You're going to go to your inverse normal, 0.5 plus your confidence level divided by 2. And then since we're looking for a z-score, the mean and standard deviation is 1. And that gives me my z-score of 1.96. You will eventually commit many of these to memory just by using them so much. So 1.96 times the square root of p hat 1, q hat 1, and this is where it's beneficial that we actually did the computations right here above, all over n1 plus p hat 2, q hat 2, all over n2. Now, once you've shown that work, you can actually just go back to your calculator and have it finish the rest of it. Now, what I'm working on here, and again, all of these things that we list are very helpful for us. We come back here and we notice I'm doing a two proportion z interval. So the test that I'm going to run, it's not a sample, it's a proportion, but it's not a test, it is an interval. So all of those are different. So we want the two proportion Z interval. And again, I'm just going to come back to this and type in all the numbers as I have them here. So 14 successes out of 80, 22 successes out of 80, and a 95% confidence level. And this gives me everything that I need to complete it. But notice it doesn't give me the formula. It doesn't even give me the actual value of my standard error. All it gives me is the confidence interval itself, which is what we're looking for here. So I get to say that my confidence interval goes from, and you want to make sure that you get your signs accurate. I believe the first one was negative, so let's check. Negative 0.228 to 0.028. 2285 to 0.0285. Okay. So that's my confidence interval. Now, even though it doesn't say interpret the confidence interval, if that's what you're doing, if you are creating a confidence interval from scratch, your final step is always interpret the confidence interval. So that's what we're going to do. So in interpreting our confidence interval, we always follow that formulaic response. We are, my confidence level, 90% confident that the true, in this case we need to go back to see what we're talking about, and for this problem, it is difference in proportions of subjects reporting drowsiness. So I'm going to put that word for word, the true difference in proportions of subjects reporting drowsiness. And I'm actually going to input here that I'm doing the improved brand, or let's just call it brand I minus brand C, is between, make sure you include your negative sign here because that will totally change your options. And since I said proportions, I'm going to write it as a proportion. So between negative 0.2285 and 0.0285. Okay. So now I get to interpret what this means. We're asking here, does the interval in question 1 provide evidence that the side effect of drowsiness is different with the new medication? Remember, the sign of the numbers indicates which one was initially bigger. So considering the fact that my confidence interval starts with a negative number, that tells me that brand C initially had a higher proportion of subjects reporting drowsiness. Now the second number is positive, which indicates that brand I had a higher proportion of subjects reporting drowsiness. And so what that means is because I is in the, or because 0 is in the interval, we cannot claim that there is a difference between proportion of subjects reporting drowsiness between the improved and current brands. So you might want to rerun the experiment with a larger sample size. And the reason why a larger sample size would be good here is because we have a very heavy proportion less than, but we have a small proportion greater than. So a larger sample size might actually improve our confidence interval, making that smaller to come to a better conclusion. So there's our confidence interval, making sure that as we go through here, you always indicate what the order of your comparison is, list the numbers that you can pull from the general setup, state your assumptions and conclusions. If your conditions are met, state that the sampling distribution is approximately normal, state what type of a test you're going to go through, show the formula before computing your confidence interval, then interpret your confidence interval always in context. This problem is dealing with the proportion of patients who suffer from cardiac disease, are depressed patients more likely to die than non-depressed patients? Now that's very important because we're talking about our population of interest here first. So the population is patients with cardiac disease. So it's not just people in general. This is very specific to patients with cardiac disease. So P is going to stand for the proportion of patients suffering from cardiac disease who die. Again, I am not denoting whether or not these are patients with or without depression because that's going to come into my actual sample breakdown. Now, my first question here is asking me what kind of design was used to collect the data. And this goes back to our previous chapter on sampling and design of experiments. Now, since we're obviously not actually giving these patients any form of depression, this is something that they naturally have, this is not going to be an experiment. This is an observational study. But we need to understand whether it's a prospective or retrospective observational study. Well, looking at this, it says we identify the patients, evaluate them for depression, and then follow the group for 4 years. Now that's going to tell me that since I've identified the patients first and then watch them, hopefully you understand that is a prospective observational study. Okay. For part B, we're asked to write the actual null and alternative hypothesis. Then we go through our assumptions and conditions, test the hypothesis, and state the conclusion. So B, C, and D are basically the full hypothesis test. So looking at B, our null hypothesis is always going to be that there is no difference between our two populations of interest here. My first population of interest that I'm going to use is I'm going to talk about those with no depression. So that's going to be the proportion with no depression. And I'm going to talk about minus the proportion with mild to moderate depression. And I believe that there is no difference. So you can either write it like that, or you can write it as the fact that the two proportions themselves are equal. If the proportions are equal, the difference between them is nothing. On the flip side, my alternative hypothesis is I believe that depressed patients are more likely to die. So that means that my depressed patients with moderate or mild depression, so that this one is supposed to be the bigger of the two. So if I'm looking at the difference between them, and I believe that my people with depression, that's the bigger number, then I'm going to be looking for this whole thing to be less than 0. Or the fact that the proportion with no depression is less than the proportion with depression when we're talking about dying from who die if they have cardiac disease. Now, before I get going, I'm actually going to stop here and I'm going to record what all of my observations are. So I'm going to stop talking about the group that has no depression. So of the patients with no depression, 67 out of 361 perished. Of the patients with depression, 89 of them, 26 died. So my first number is 67. My first sample size is 361. My second sample has 26 who died, and my sample size for that one, sample size, is 89. It doesn't state it, so we're going to use an alpha level here of 0.05. Now, in order to go forward with this test, what do we have to have? Assumptions and conditions. For my assumptions and conditions, the first thing that we're going to be looking for is whether or not this was random and independent. Again, we can't necessarily pull people randomly. People have to volunteer to have their information, or we can only go from people that we have the information from. So we're going to say for part C that we hope it is a representative sample. We can't really do much more than that, but hope. The next thing that we're going to do is we're going to say that the treatments or the non-depressed versus depressed patients are independent. Okay, so that talks about my independence, my randomness, and my independent groups. Now I'm going to deal with my sample size. So we dealt with 450 people total, and that definitely should be less than 10% of all with cardiac disease. We need to talk about my success failure. So my successes for the first group are 67. Our number of people that did not die were 294. We had 26 with depression, and the number that died would have been 63. All of those numbers are greater than 10, so large enough. Okay, so we get to state now that we're going to proceed, or conditions met, sampling distribution is approximately normal. We're going to do a 2 proportion, and this time around it is a z-test. We're testing our hypothesis, so this is a z-test. So there's our assumptions and conditions. Now we're actually going to test the hypothesis. For the hypothesis test, you need to recall that always with a hypothesis test, you are going to pool your samples. This is very, very critical because it's going to affect how you calculate your standard error. So what I'm going to do here is I'm going to say p hat pooled is, and it's going to be your total number of successes, so that's both success groups, 67 and 26, out of my total sample size, 361 and 89. So that is going to give me 93 out of 450. That's my p-hat pooled. We're going to use that to find your standard error of your standard error pooled. So my pooled standard error is going to be the formula. And again, you don't need to write the formula, you just need to do it. But it's going to be p-hat pooled, q-hat pooled, and that's times 1 over n1 plus 1 over n2. So in this case, my standard error pooled is going to be the square root of 93 over 450. 450 minus 93 is going to be 347. My apologies. Okay, then 1 over sample size 1, 1 over sample size 2. And we're going to use that because we have to calculate my z-score. Your z-score is your observed difference minus your null hypothesis divided by the standard error pooled. So for my case, that's going to be the difference. Where were my numbers? Here they are. Which was 67 out of 361 minus 26 over 89. Now, my null hypothesis here was that there was no difference. So that number here is 0. All over, and I'm just going to write SE pooled. Some people will choose not to write SE pooled here, and rather than writing the formula separately, they will take all of this and put it there. That's totally up to you. It does not matter. But once we have that written down, we can actually go through and do the test. So I'm going to leave this up here so I can see some of my numbers to start with. I'm going to grab my calculator. And this is where we start to love our calculators. They make life so much easier. So I'm going to go through and do a 2-proportion z-test. Okay, my number of successes for the first group, total number of in my sample size, successes in the second group, sample size for the second group. And my alternative hypothesis, remember, was less than. Be very careful to make sure you choose the correct one here because it will totally change your computations. So I'm going to calculate this and absolutely love that it gives me everything that I need to know. It gives me my z-score, it's negative 2.22. Just round your z-scores to 2 decimals. My p-value is 0.0131. So let's write that down before we get any further. So my z-score was negative 2.22. And so in order to make my conclusion, I want to make sure that I state the probability that my z-score, alternative symbol, less than, negative 2.22, is equal to what your p-value was, so 0.0131, if I am correct. Yes, I am correct. So now I've done all of the mechanics that I need to actually make and state my conclusion. Now we get to state with a p-value of 0.0131, which in this case is less than our alpha of 0.05. Remember, we always not just want to say that it's less than our alpha, but actually include what alpha is. What do we do when the p is low? We reject the null hypothesis. And that's the general conclusion. Now we have to interpret that conclusion. And we get to state, our evidence supports the claim that, and we go back up to the problem, and we're basically going to say, depressed patients are more likely to die than non-depressed ones if they have cardiac disease. That patients with cardiac disease are more likely to die if they suffer from depression than patients without depression. Okay? All of that goes together for part D. Now, it does go on and it says for part E, explain in context what your p-value means. Now, recall your p-value is the interpretation of that number 0.0131. So we get to say that the p-value is always if the null hypothesis were true. So we could say if there was no difference in proportions of deaths between patients with and without depression, the likelihood of seeing our results, our sample, is 0.0131. Basically, that tells us that it is not likely. And that not likely statement is because it's less than our alpha. And the very final portion says if our conclusion is actually incorrect. So an incorrect conclusion here. We rejected the null. And we're saying that we shouldn't have. Remember, that's kind of like our pregnant man saying he's pregnant when he really is not. We rejected the null. That is our type 1 error. Okay. And now that problem is complete. So in this video, we have now completed a confidence interval and a hypothesis test. And you can see what needs to be set for each of those. For the hypothesis test, again, you're identifying your proportion. making sure it makes some sort of an allusion to what your population of interest was. So this is patients suffering from cardiac disease. You clearly label your null and alternative hypothesis. Because the null and alternative hypothesis contains a directionality here, so it's the no depression minus moderate or mild depression, you don't need to specify or spell that out someplace. It is beneficial if you do that. We list all of our data that we gather from the sample. We talk about our assumptions and conditions, listing them all out in context. We state that our conditions are met and that we're talking very specifically here, guys. This is extremely important that you note that this is a sampling distribution and that it is approximately normal, and that we're going to do a 2-proportion z-test. Now, the z-test was different than a confidence interval because a z-test uses a pooled standard error. And you're done.